Hello, my name is ionisation. I am from Institute of Atomic Physics and Spectroscopy of the University of Latvia. I would like to test review radon monitor ionization chamber. It's unique that it runs on two AA batteries for 2 years with Bluetooth and proprietary LoRa. It is made in Latvia by Technica Aranet, a company that is specialized on wireless micropower sensors and microwave data links since year 2000. Radon sensor is called Plus Home for home use. It has electronic ink display which uses very little power. On the side is encoder with buttons. To activate scroll menu, choose units picocurie or becquerels per cubic meter to set alarm levels, etc. Averaging intervals are short term, 1 day, 1 week, 1 month, and data are stored on device for 35 days to be read out to telephone. On a mobile phone, there is application from upmarket, and it can show graphs of the temperature, humidity, pressure, and of course radon. And now I will talk about radon levels. In the outside air, radon concentration on average is 0.4 picocurie. And the safety level is set 10 times this outside value. So safety level is 4 picocurie. And in the graph on the right side, we see calibration at different radon concentrations. The red line I draw was safety level for picocurie. It is exactly 200 becquerels per cubic meter. And we see the sensor is sensitive up to 4000 becquerels per cubic meter. It's linear. And 200 becquerels per cubic meter in 1 hour, one gets 30% measurement accuracy, which increases by increasing collection time. Now about construction. The ionization chamber is made from black color electric conductive 3D printed plastic. Its outside is at 0 volts. Since the device only connects by radio, the central wire as well as circuit board is at 60 volts voltage. This is unusually low voltage for radon detectors. Typically about 450 volts is used. Circuit board ion chamber side is gold plated to prevent the electric oxides and static electricity charges. Technica works a lot with microwaves and use gold plating quite often. The central wire has a cross at the end. This allows to collect ions from larger effective volume. There is also variation in Pro series, a smaller chamber which can be used to monitor elevated concentrations. It is also 3D printed from conductive plastic, and pores in the plastic let radon through. There are two kinds of conductive plastics. One is with low resistance that it can heat up with current, and the other is just electrostatic leaking the voltage. I think here they use the plastic which is with low resistance. And then there are two circuit boards. One contains analog circuitry, and the second board contains microcontroller and transmitter antenna, as well as 3-volt lithium battery. About electronics, micropower operational amplifier is used that can run from 3 volts. I guess it is TLV 9042 from Texas Instruments, but I have not opened the case to check it yet. Many other detectors use a field effect transistor on the input, but in this case it would draw about 1 milliamp and would too quickly drain the battery. Sensitivity to external perturbations. Plastic case is somewhat sensitive to static electricity and high voltage sparks nearby. Also, deforming the plastic ion chamber by fingers can produce clicks as the capacitance of ion chamber changes. But at normal operation, it is not possible to deform the ion chamber inside the protective outer case. Humidity and temperature sensors are included in the circuit. By testing the device in different humidity conditions over saturated salt solutions, producers observed that there was no humidity correction necessary. This is quite strange. Usually there is dependence on humidity. High voltage for ion collection is only 60 volts. It is made by short pulses charging a capacitor. When the voltage drops below a certain threshold, it is recharged. When there is high ambient humidity level near condensation, the device monitors that there is too often happening recharging of the high voltage capacitor and displays a warning and switches off to save the battery. Barometric pressure correction. Atmospheric pressure is lower in mountains and it would be logical to correct for it. But it is not the only reason. See the next point. By testing radon meter inside a vessel with an elevated pressure, it was noticed that air ionization becomes weaker at higher pressures. So it was necessary to introduce a pressure correction. Air pressure sensors are generally used in many radon meters. In basements, radon is pulled out of soil when air pressure drops outside and radon concentration in the basement rises. Vibrations. The central conductor is thick, so it is not sensitive to vibrations. Only shaking the device wildly can produce false clicks. Some commercial devices include a vibration sensor that blocks counting during vibrations. Vibration sensor is used in certified radon counters to detect if the device was moved, so-called anti-tampering. About device calibration. A 50-liter large radon chamber with radon source and laboratory-grade radon measurement device was used. Several relative humidity reference chambers using saturated salt solutions were prepared. Laboratory-grade temperature humidity chamber apparatus was employed. Variable pressure chamber was home built. One can download application from Google Play or App Store. There is application for home use and another is for professional use, Aranet Pro. It is a concentrator which collects signals emitted by proprietary LoRa. And it is more often used in offices and greenhouses and schools. Here you can see all products made by Saftechnica. They are very good on microwave antenna for internet data link. And microwave signals can propagate in air with the speed of light, which is faster than through optical cable, and this gives advantage in some business operations. I was happy to visit Saftechnica factory in Riga, Latvia, and thanks to the owner, electronics guru Didis Liepkalns, and Dr. Physics Kristaps Bergfelds for the tour. At the entrance, they have a demonstration stand where their wireless sensors are exhibited, and they here have a demonstration on a heat exchanger. So we have come to conclusions. The new Saftechnica Aranet Radon sensor home is impressively energy efficient and can run on 2 AA batteries for a couple of years. Device is easy to carry around and measure in places with no electric power, like basements, caves, wells. It will allow to continuously monitor radon in households and workplaces, so that people can learn how to optimize the ventilation, or if they need to install radon vapor barrier. And at the end is a quick tip how to measure soil radon. Simply put the sensor on the ground or dig a hole with a spade and cover with a bucket and monitor with your phone. Thank you for attention.